All right, welcome back everyone to Outstanding User Interfaces with Shiny Book Club. Today we are going to discuss chapter 14, which is about mastering Shiny's events. So there are two main sections in this chapter. The first one is the 14.1 that talks about getting the last changed input. So any input, we want to know what that input was, what was its value. And the second section in this chapter is creating a custom overlay screen using the Shiny object. So we have seen different aspects of the Shiny object. We have seen Shiny connected in the previous chapter that tells us that now the Shiny app is ready and the connection through the WebSocket between the server and the client is ready. So in this first section, we are going to see how do we find out that the last input change was which one and what was its value. And one question that I was thinking about was where could this be useful? Why do we want to know the last change input? So one application that is briefly mentioned in the chapter as well is logging. So we want to know what is it that the users are providing as inputs and what is the last input and what was its value. So we are going to take the first example mentioned here in 14.1.1 that shows us that there is a difficult way to get the last input by using Shiny's own capabilities from the user's perspective using the UI and server components that we are familiar with. So here we have that app. Angel, can you see my Art Studio Cloud?
Yes, I can see.
Okay, great. So here we have in the Shiny app a Fluent page with text inputs and a verbatim text output. And what we want to know is we want to know out of these two inputs, which one, actually there's third one as well. So we want to know which one was the last one that was changed and what was its value. Let's first take a look at the app and then we'll see the details. So right now it's showing us that the last value is the input XC. If I make a change here, then it tells me it's text A, here B, and now if I make a change here, now it's C. Let's change A again. So this is the main motivation. This is what we want to get. Now let's take a look at the server part. So we see that first there is this values object that is looking at it has a reactive values object which contains last updated. Currently it is null. Then what we do is we use the observe, and then for each single input, in this case there are three inputs, we are looking at the input X, and then from the values we are getting the last updated value. We are actually assigning to this object the value X, the value of the input. So it goes to this reactive value values, and it's updated using this syntax. And at the end, we are just showing that as shown here through the verbatim text output. So this is not relatively an easy thing to do because we have to look at every single input and we need to use the server to continuously observe and find out the last change value. So this was the main motivation of why we need to look at some client side processing instead of server side that could help us get the same result, but without much processing. So for doing so, we want to use JS and we want to use Shiny input changed object. So this relevant event has five properties. It provides us the name of the event, the value, the input type, the binding of the input, and the element, which is the related input in the document object model. So let's take a look at this one. So I'm going to run this app first. In this case, they're a single input. If I make any changes here, it should show us the value in the console. So I'm going to first open this in the browser tab. Let's take the inspector tool. So I'm on Firefox. Inspector tool is slightly different. And here, if we go to console, then you can see that here's the shiny input change object. It tells us the timestamp and the input type. So currently the input type is empty. If I enter, let's say, a number here, now it tells me the value, and it also provides me information about the binding. It also tells me that this value was changed from input test dot shiny dash input dash text and so on. So this is the test is the ID. If we take a look at the app again, the test is the ID of our input. That's why we are getting that information. So every time I make any change to this, it will update the console result. So in this case, we see value O and then again the shiny input object. Let's see how this was created. So in this case, the input is a single one. There's nothing going on in the server, but on the client side, we are using jQuery to use shiny input changed, and we are just logging the event. Next, this is the same thing, I think. Yeah, there's another extension to the same thing using the event.binding.name.split. So this is, in my opinion, still complicated. Uh, Definitely complicated compared to the server code that we saw in the first example. But this is all going on in the at the client side. So this is the advantage. We are not continuously using the processing in the server. So let's take a look at this one. And here, one thing that I found was since the update to the Shiny package, what is mentioned in this chapter, this example, it doesn't work, at least in my experience. And I was investigating this more. I found that the shiny dot set input value has a different behavior now compared to previously. So if I run this example first, let's first run it from the package directly and see if we get the same result. If I make any changes here, we don't see the update here. And let me open this in the tab. Let's look at inspector tools and console. And so if I make any changes here, there's some type of error, which means that this code is no longer valid. And we can try running, oops. We can try running this code directly as well to have another version that is working, but we'll see that in a moment. So let's run this one and then open this in the browser and inspect tools, console. Again, the same error. It's just essentially the same code, so it's not really working. But let's take a look at what they were trying to do here. So we have shiny input change again used. This time instead of logging the events, they're using shiny.set input value. And the value that they are setting is last changed. So let's see. Here we have a verbatim text output called as last change, but here we are setting an input with the same ID last change. Probably that is the problem. I'm not sure. And then we have the name of the event, the value of the event, and the type of the event and its binding. So using the event.binding.name.split and one at the end, we get the information about their binding as well. So this is the main purpose of running this code. But I think because the input value that is being set has the same ID as the verbatim text output, probably that's why this code is not working. Um, but in any case, let's comment this out and let's run this code, which does work. So in this case, the change is that we have the test ID for our text input, and we're using that here, and then we are providing the input, and then we are using shiny.setInput. And here I changed the name of the, sorry, the ID of the input here. Instead of last change, it is now last input changed. And we have the output as last changed output. So the rest of it is similar, the name, the value, and the type. If we run this, yeah, and in the input side, sorry, on the server side as well, we have the last change output, which is essentially getting the last input changed of what is set here. So server is only used for rendering the result, but not actually getting the result. That result is still being obtained from the client side. Now let's see in the console. And now we get this result. So in the console, we still get some kind of type error, but now I'm able to see the name, the value, and the type.
Yeah, like it was showing an event object somehow. It's like the event object was not accessible at that level, you know?
Hmm.
Yeah, maybe you are changing the scope here because you say, okay, on document ready, perfect. Once the document is ready, you have the test on, you are changing the scope of the function.
Yeah, maybe this is, you're right. This could be a possible thing that if you add this to this, maybe it works.
Yeah, yeah, I think that's the difference because you are changing the environment. When you say, oh,
Mhm.
under the test variable, because I was checking in the documentation of events that they happen at some level, you know?
Hmm.
So I think it's an element level. And I think now they are changing. That's the difference to me. You know, that was a define the most different part I see. And of course you are simplifying a lot because you just place test, you are not using the split part. But yeah,
Yeah,
I think that I was checking the bindings. Okay, I can see the binding in the console, perfect, in the first example. But like, even though I see that it have a name, I see the binding, I see the elements, everything in the console, I
yeah,
cannot get access. I think that's the solution. Changing the scope of the function that you did for test.
yeah, yeah. Right. Um, Yeah, so anyways, this was the expected output that we should get. And I think since the update in the Shiny package, something is it's different as Angel mentioned, and that's why we didn't get the exact same result. And here is another event, which is prevent default event, and that would essentially cancel the input. So it says here that Shiny input change is also cancelable. That is, we may definitely prevent the input from changing its value. So if we take a look at this example, so here, if I make any changes, we don't see any output, and that's because we have used event dot prevent default. So this is still using the same syntax as before, but this is working. This is preventing the input to change. I'm not sure what would be the application of this. Why would we not want the inputs to change? But it's interesting capability. Um, Next is a practical example from Shiny Mobile. Fortunately, there is no difference between this behavior and Shiny Mobile version 2 that is available. So I installed the latest version and this example is still running. So Shiny Mobile directly provides us with last input change, which is very convenient. We don't have to write the JavaScript code by ourselves. They have written it for us. So all we need to do, let's take a look here. All we need to do is just directly use input last input changed, and we can get the last input changed. In this case, there are multiple inputs. So there's this text input and the range input. If I change the text input first, we get information about name is text, value is this, and type is text input. If I now change the range input, now we get a different result. So using just input $sign last input change, we can get the latest changes in whatever input was used the last. So this way it is very easy to use. And I think this is probably created for Shiny Mobile to log and get information about people's behavior. Shiny Logs is another example, which does a similar thing. And it uses this thing called as shiny logs underscore last input, and similar to what Shiny Mobile has done. So we need to provide this as well as track usage for storage mode. In this case, they are not storing the results, but I guess this is useful if you want to store the results of what your users are entering in your inputs. So let's run this example. If I change the numbers, so here we do get slightly more information. So we also get information about time. We do see the type as before. Now we also see the binding directly. And if I change the slider, then we get information about the slider and values and types and so on. So this is another way to get user behavior information from Shiny Logs package. There's another one which is not mentioned in the chapter. It's called Shiny Telemetry. And Shiny Telemetry can be connected with an external database pretty easily. And I think that's the default behavior as the package mentions. I tried it in one of the apps and it's easy to look at the result of every single input by every single user, or as many times as the user provides a new input. So it's
What's the
great to,
package name? Can you right?
it's Shiny Telemetry.
Okay.
Let's see. Yeah, this one, Shiny dot telemetry. And let's see. Yeah, so we need to provide this object, the telemetry new, and then it will automatically in the using JavaScript, it will get that information. So just like other JavaScript based packages, we need to specify use telemetry to get all the dependencies,
To add the
and
dependency, yeah.
then we get start session, and that's it. And then any number of inputs we have, it will get all the information about them and store it. If you connect this to an external database, it will save it there.
Okay, perfect.
All right.
Thanks for sharing.
Next is section 2 of the chapter, which is custom overlay screens. Now, custom overlay screens also use JavaScript events behind the scenes, and that's why the Vader package uses those JavaScript events to create very nice and useful screens. So one example is the preloader from the Vader package. And under the hood, it uses the shiny idle event that tells us as soon as all the inputs are ready and nothing is being changed, nothing is being processed, then the event is shiny idle. And uh, shiny connected, we have already seen. Shiny session initialized also appears after shiny connected. That tells us that session is now ready. And so using the shiny idle and some of these events, it creates the preloader. So Vader underscore preloader essentially uses this code. It has a shiny idle. So it's looking for the shiny idle event. And whenever it is triggered, it's going to hide the Vader. So as long as it is being processed and shiny idle is not active, the Vader screen, the overlay will be running. And as soon as it is done, hide underscore Vader will be run. So we have this example using the Vader package. Let's see how that looks. So let's first see the app. So this is the initial preloader window, and then we get to the app. If I make any changes, then the preloader runs again. Actually, preloader is only for preloading the app. There's another example after this, which will show that overlay after every change in the input. In this case, it's just a single preloader at the beginning of the app, which is essentially using Shiny Idle. So for Vader package, we load the library, we say use Vader, and then we say Vader underscore preloader. We have seen the jQuery code for that before. And then we normally type our plotting function and render plot. And in this case, to simulate a long process, it's provided sys.sleep. And so the first time the app loads, it will show that Vader preloader. And when shiny idle is triggered, then it hides the screen. The second example uses load on busy. So it exploits two events. It uses shiny idle and it uses shiny busy. So here again, within the JavaScript code, we see shiny busy, and then it uses the show underscore Vader function. So as long as this is triggered, show underscore Vader is running. And then when it is idle, then hide underscore Vader is running. Let's see what that looks like. So this is the first time that the plot was being created. We get this. Now if I change this, now we again get another screen. And this is because this time we are not only using shiny idle, but we are also using shiny busy. In the previous example, we were only using shiny idle. And I think this was the last example for this chapter. We are done.
Yeah, perfect. I know that waiter have more options to show more waiters because that's just, the supervise. It's a really great package. So, and that's it. Yeah, really good.
Yeah, I
Great
think one
presentation.
you mentioned, I just reminded me of use busy indicators, something like that, from Shiny. Let's see, busy indicator for Shiny apps. No, this is a package. Now in Shiny, there is this busy indicator
Okay.
that we can use. Let's see. Yeah, busy indicator options, and I'm looking for the main function that is used in the server. Yeah, right here, use with indicators. So if you provide this in your Shiny app, I think it's as of version 1.8 of Shiny. Uh, you don't necessarily need to use Vader in all cases. It
Okay.
will have a spinner, and you can also use your own spinner. So it is like Vader, nice, and it's inherent to Shiny now. But with Vader, yes, there is much more flexibility. You can do a lot.
Okay. Perfect.
All right, so this is uh, everything for today. I'm going to stop.